guys, welcome back to my YouTube channel. Today I am going to solve day 30 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today we are going to solve problem number 2699, modify graph edge weights. Okay, so this is hard level problem marked by Leetcode, but it is going to be very interesting problem. Okay, you are going to learn a lot of concepts in this problem, and in the end we will discuss about the time complexity for this problem. Okay, so let's read the problem statement first. So you are given an undirected weighted connected graph containing n nodes labeled from 0 to n minus 1. Okay, so if n is equal to 5, simply means that we have nodes numbered from 0 to 4. Okay, and an integer array edges where edges of I is equal to a, b and w. Okay, so simply means a to b we have path and b to a we have one path. Okay, since this is undirected weighted graph. Okay, and weight is given to us, indicates that there is an edge between nodes a and b with this weight. Okay, some edges have a weight of -1 while others have a positive weight. Okay, so our task is to modify all the edges with weight of -1. Okay, only these edges we can modify with weight of -1 by assigning them positive integer values in the range 1 to 2 into 10 raised to power 9. Okay, so this is the value that we can assign to the edges who has weight of -1, so that the shortest distance between the nodes source and destination, okay, source and destination is going to be there in our problem, becomes equal to an integer target. Okay, so here see this problem, this is going to be my source and this is going to be my destination. Okay, and to reach from source to destination I need this much target. Okay, so I need to see whether I can achieve this by modifying the edges whose weight is -1. Okay, only those edges I can modify, right? If there are multiple modifications then that make the shortest distance between source and destination equal to target, then any of them will be considered correct. Okay, we have to return an array containing all the edges, even unmodified ones. Okay, all the edges we have to return in any order if it is possible to make the shortest distance from source to destination equal to target, or an empty array if it is impossible. Okay, if it is impossible, just return this. Note, you are not allowed to modify the weights of edges with initial positive weights. Okay, we can't modify those edges, right? So I hope that you guys are clear with the problem statement. So first let's do one thing, let's draw this. Okay, so n is equal to 5 simply means that I have nodes from 0 to 4, right? So how I'm going to draw this? So let's do that. 4 to 1 there is one edge, okay, with this weight. So okay, so let me draw that. So let's suppose that this is my node 4 and this is my node 1. Okay, in between we have one edge, right, and the weight is -1. Okay, then 2 to 0 there is one edge. Okay, so let me draw that. So let's suppose 2 is here and 0 is here. Okay, 2 to 0 there is one edge with weight -1. Okay, so let's do that. Then 0 to 3 there is one edge with weight -1. Okay, so 0 to 3 there is one edge with weight -1. Okay, and then 4 to 3 there is one edge with weight -1. Okay, so 4 to 3 there is one edge with weight -1. Okay, so this is how my graph is going to look like, right? So initially n is equal to 5 simply means that I have nodes from 0 to 4, right? And these are the edges given to us. My source is going to be this one, right? Source is 0 and destination is going to be this one. Okay, and I need to move from my source to destination with this much target. Okay, target is equal to 5. So this is possible now. I can modify this edge, I can modify this edge, I can modify this edge. So it is possible in this case. Okay, so what happens, let's suppose if 0 to 3, okay, so let me draw it like this. So if 2 is here, 0 is here and 3 is here and 4 is here and then 1 is here. Okay, and this is going to be my destination, this is going to be my source. Okay, so now let's suppose if 0 to 2, 0 to 3 there is weight like 3. From 3 to 4 there is weight like 2. From 4 to 1 there is weight like -1. Okay, and 0 to 2 there is weight, let's suppose -1. Okay, so in this case what should be my output? Okay, so my target is 5. So can I obtain my target as 5? No, I can't obtain my target as 5. 3, it is fixed, I can't change it. 3 to 4, I can't change it. 4 to 1, I can change this -1. Okay, can I change it to 0? No. See here, your task is to modify all the edges with weight of -1 by assigning them positive integer values in the range of 1 to 2 raised to power 10 raised to power 9. Okay, so I can't modify this, right? So definitely it is going to just return me an empty array. Okay, or an empty array if it is impossible. So it is not possible, right? So let's suppose if instead of this -1 here, if it is 6, then also it is not possible. I can't change this, right? This is not possible. Again empty array. Okay, now let's suppose this is -1 and this is also -1. Now tell me, is it possible? Yes, it is possible. I can change it to 1. I can change it to 1. So now this is possible. So now it is going to give me the updated result. Okay, so this is one case, right? Now there is one more case. Let's suppose 0 to 3 I can move to 1, or 3 to 4 I can move with 1, and 4 to 1 I can move in 2. So right now again it is going to give me just an empty array, because here see 2, 3, 4. Okay, total 4. In just 4 distance, okay, I can reach from source to destination, right? So in that case also it is going to give me return an empty array. Okay, and here if it is -1, then it is possible, because I can change this -1 to 3, then it is possible, right? Then it will give me the correct result. Okay, so I hope that you guys are clear with this one. Okay, so now let's see how we are going to solve this problem. Okay, so let's do first step 1. Okay, so in step 1 what I'm going to do, I'm going to build the graph excluding the edges with the -1 weight. I'm not going to consider all these edges with -1 weight. Okay, so initially you see all the edges has weight -1 initially. Okay, so how my graph is going to look like? So we have nodes from 0 to 4, right? So what I'm going to do here, I'm writing my nodes. Okay, so 0, so this is a graph for 0. Okay, so you can just simplify read it as graph of 0, graph of 1, okay, node 1, graph of node 2, graph of node 3, graph of node 4. Okay, now from 0, can I move to any other node, but weight should not be -1? No, it is not possible now. From 0 if I move to 3, weight is -1. From 0 if I move to 2, weight is -1. So I can't move anywhere. So it is empty initially. All these nodes are empty. I can't move anywhere to any other node. Right? This is going to be my step 1. Okay. Then after that, we have to compute the initial shortest distance from source to destination. Okay, so from source to destination, from 0 to I need to move to this destination, and initially there is nothing in my graph. Okay, there is nothing in my adjacency list. Okay, so all these -1 I'm not considering, so simply it is going to return me infinity. There is no path, direct path, right? There is no direct path. So I am going to create, okay, so how this Dijkstra's algorithm work, so we will discuss further in code actually. Okay, so initially from this 0 I need to move further, right? 3, 4. Okay, I will just calculate the distances. Okay, so I am going to set all these to infinity initially, and then I am going to calculate the minimum distance that I am going to take to reach from my source to destination. So from 0 to 0 I can simply write it 0 now. Okay, since if my source is 0 now initially, and I am at source, I am initially at my source only, so I didn't take any distance. Okay, didn't take anything. From 0 to 1 I can't move, because there is nothing here, right? Infinity. 0 to 1. Okay, I can't move anything anywhere, right? 0 to 2 I can't move anywhere. 0 to 3 I can't move anywhere. This is nothing but the shortest distance I'm going to take to reach at this particular nodes. Okay, so I can't move anywhere. So initially it is just going to return me infinity. Okay, so if it is just going to return me infinity, then simply means that we have to modify these minus ones to some other values so that we can obtain our result. Okay, so what is going to be my step number 3? My step number 3 is going to be iterate through each edge to adjust its weight if necessary. Okay, so 4 to 1, if I am moving with minus 1. Okay, so I can change it. So let's do one thing now. Let's change it to plus 1. Okay, minimum distance. Okay, minimum post integer. So here I am changing it to 1. Okay, so now my graph is going to look like this, S3. Okay, this is going to my step 3. So 0 I need to modify, 1. Okay, all the nodes I am modifying in the graph. 3, then 4. Okay, so here I'm saying 4 to 1 I can move. Okay, so 4 to 1 I can move, and 4 to 1 and 1 to 4. Okay, so all these are possible. Okay, initially these are empty, right? And I am adjusting the edge weight to 1. Okay, I am adjusting the edge weight to 1. Okay, this is what I am doing in my step 1. Okay, after doing this, after adjusting it to weight to minus to 1. Okay, so I am only adjusting the weight to 1 if it is minus 1 initially. Okay, otherwise I am not going to make any changes, right? So this is done. Then after that, once we set this, then after that again I am going to check this run Dijkstra algorithm. So I will see. So here from 0 to 3 I am again moving in minus 1. So I can't reach to my from my source to destination, right? Again I only set this to 1. These are infinity. Okay, treat these as infinity. Minus 1 distance is infinity. So I am not reaching in just 5. Okay, I need to reach in just 5, right? So after that, let's iterate over other edge. So 2 to 0 I can move with minus 1. So 2 to 0, so let's modify it to 1. Okay, so I have modified it to 1. Okay, so now we can move from 2 to 0 and 0 to 2. So here 2 to 0 we can modify move, and 0 to 2 we can move. Okay, this is done. Now after that, let's move over the other edge. 0 to 3 minus 1. So 0 to 3 minus 1, this is minus 1 now, so we can change it to plus 1. Okay, so I have changed it to plus 1. Okay, so 0 to 3 we can move, right? 0 to 3 we can move. So here I am writing 0, and here I am writing 3. Okay, this is done. Now after that, another edge 4 to 3 I am moving in minus 1. Okay, 4 to 3 I am minus 1. I am going to change it to plus 1 first. Plus 1. Okay, positive 1, right? So 4 to 3 and 3 to 4, simple meaning, right? This is what we can do, right? So now here I have set all these to 1 1 1. Now I will calculate the distance from my source to destination. So here 0 to 3 1, 3 to 4 is 1, and 4 to 1 is 1. Okay, so distance 3 is less than equal to 3 is less than 5, right? 3 is less than 5. Okay, so in this case what I'm going to do, my 3 is less than 5, right? So in that case I'm just going to, this is my last edge now, 4 to 3 minus 1. So instead of updating it to 1, I am going to think that let's update it to 3 now. Why should I modify it to 1? Because if I just modify it to 1, I will get 3, and 3 is less than 5. Okay, so if I just modify it to 3, then in that case from source to destination I will get the total output as 5, and I need 5 only. Okay, it is possible. So here in 3 to 4, instead of changing it to 1, I will directly change it to 3, right? This is the best case now, if I just change it to 3, because this is my last edge. This is the last edge, and I can change this minus 1 to any positive integer ranging from 1 to 2 raised to power 10 raised to power 9. Okay, so I am side by side calculating how much I need here to get my perfect answer. Okay, so here instead of 1 I am just going to change it to 3. Okay, so this is what we need to do here. Okay, so I hope that you guys are clear. So now here, see here, from 0 to 2 we can move, and 0 to 3 we can move. Okay, so here how my Dijkstra is going to work. So let's little bit check that as well. Okay, so here Initially I'm going to take my min distance array, okay, from 0 1, okay, this is 2 index, this is 3 index, and this is 4 index. Okay, I'm going to set all these to infinity initially. Okay, then this is my source, right, and this is my destination, and this is what I need to fill, right. From source to source I am just going to reach in 0 now, so I can change it to 0. Okay, so now this is done. Now now I am going to implement the min heap. Okay, so in my min heap, okay, so let's suppose this is my min heap. Okay, and in my min heap I am adding what, I am going to add the value of my source. Okay, so my source value is nothing but 0 here, right. So I am going to add my source in this min heap, right. So here let me do that, source, and also I am going to add the distance. Okay, so source to source 0 only. Okay, this is what I'm going to run. Okay, going to use. So this is my min heap, and my min heap is based on this distance. Okay, so if any value is less than 0, okay, that will go on top. Okay, so just understand it like this, if any value is less than this number, okay, then that will go on top. Okay, based on that my min heap is working. Okay, so once we get all these weights, right, 0 to 2 this is weight, 0 to 3 this is weight, 3 to 4 this is weight, 4 to 1 this is weight. Okay, so now let me just write it here now. So 0 to 2 we are moving in one weight, 0 to 3 we are moving in one weight, 1 to 4 we are moving in one weight, 2 to 0 we are moving in one weight, 3 to 0 we are moving in one weight, 3 to 4 we are moving in three weight. Okay, and 4 to 1 we are moving in one weight, and 4 to 3 we are moving in three weight. Okay, so these are the weights. So now what I'm going to do here, initially my this min heap is not empty, right. So I'm just going to pour just going to check all these values. Okay, u and d. Okay, so this is nothing but my u source, and this is nothing but my distance. Okay, okay, so now see, from 0 I can move to this 2 with just one weight. Okay, so 0 to I can move in one weight. Okay, so let me just mark it 1. Okay, so now from 2 can we move to any other position? From 2 I can move to 0 with one weight, but I don't need to modify, right, because it is 0. Okay, this value is less, so I don't need to modify. Okay, so this is done. So we have covered this 2 completely, right. So we have wasted it. Now from 0 I can also move to 3. Okay, so from 0 to 3 if I go, I can move in how much distance, 1. Okay, so I am going to update it to 1, right. I updated to 1, right. So here I am updated 1. Now from 3 if I want to move to 4, then the total here, see, it is taking weight as distance as 3, right. So 1 plus 3 is 4, so here I have to update 4 now. In infinity this position I have to update 4, right, and this is correct now. From source if I want to go to this node 4, okay, 0 to 4 I want to move, so this is 1, and then this is 3. Okay, 1 plus 3 is 4. Okay, then I am moving here, right. So then after that I have covered this 3 completely, right. I have covered the 3's children as well, right. So 3 I am just marking it as wasted. Okay, I have done that. Now 4, okay, so 0 is also done. I have wasted 2 3, 0 is also done. Okay, so here I am just going to mark it done. Now from 4 I can move to 1. Okay, from 4 I can move to 1. Okay, so here from this 4 I can move to this 1. Okay, so total how much it's going to take? So here it is 1, 0 to 3 1, 3 to 4 3, then 4 to 1 again with the one weight. So total it is going to be 5 here, and 5 is less than infinity, so I am going to update it 5 here, right. So here in the end we have to just return the minimum distance of that destination. So minimum distance destination from source I want to reach, so it is going to be 5, right. So here how I am doing that, so distance, okay, 1, and I am going to add this value. Okay, so 1 plus this weight, overall weight, okay, whatever the value is there, 4 plus 1 is 5. Here it was 1, 1 plus 3 is 4. Okay, so this is how I'm going to update, but you guys will get more clear understanding while doing the code for this one. So let's move the coding part. So first do one thing, first create one graph. Okay, so here private graph is nothing but going to be a list of int arrays. Okay, so int arrays, and here let's name it as graph only. And we have some values, right, given to us here. If you see the problem statement, 2 into 10 raised to power 9. Okay, so let me just set it as infinity. Okay, so let me create just variable for this one. Okay, so here write private static final int and inf. Okay, so set this value as 2e9. So here just give it as int. Okay, this is done. Now after that, first we are going to write our step 1, which is nothing but build the graph excluding the edges with the -1 weight. Okay, so let's just first initialize this graph. Okay, graph is equal to new array list, and inside that just run one loop for int I is equal to 0 and I is less than n I plus plus. Okay, and for all the graphs we need to create one array list. Okay, graph of I is equal to new array list. Okay, this is done. Then after that we have to iterate over all the edges one by one. And now inside this if, so we have three values, right, in the all edges. So if this value is equal to -1, then we have to exclude that. So here I'm writing if h of 2 is not equal to -1. Okay, then in that case only go to the graph. Okay, in the graph for that particular edge. Okay, so here edge of 0. Okay, so I have to create this. Okay, for 0. So right now since all the weights are -1, okay, initially, so that is why it is empty. Okay, but if it is not empty, then what we need to do? Okay, so that's what we are doing here. So here at 0, okay, in that particular graph of h0 I have to add new int. Okay, new int array I have to add, and in that array from this particular source I need to write one destination. Okay, where I'm moving. So here I'm just going to write edge of 1, and what is the total distance or weight? Okay, whatever you want to say here, edge of 2. Okay, this is what I need to do here. Okay, so now this is done. Then same way now, so this is from source to target. Okay, so you can say like this, or from target to source, this. Okay, so here now see here, so this is like this, from 4 to 1 and 1 to 4. Okay, u to v. Okay, so let's study it as u, this is v, and this is weight. Okay, so u to v and v to u now we need to write. Okay, so here graph dot edge of 1. Okay, and here add 0, and yeah, that's it. Okay, this is done. So now after that we have to compute the initial shortest distance from the source to destination. Okay, so int current shortest distance. Okay, so here I'm just going to run the Dijkstra's algorithm. So here I'm just going to call this method run Dijkstra's. Okay, and inside this I'm just going to pass my number of nodes, what is my source and what is my destination. Okay, so these things I'm going to pass here. Okay, and after that I'm just going to check if current shortest distance is less than my target value. Okay, if it is less than target, then in that case I'm just going to simply return an empty array. So new int 0 0. Okay, so this is just going to return the empty array. Okay, so this is going to be my step 2. Okay, and after that I'm just going to create one boolean matches target. Okay, so this value is going to be set to true if my current shortest distance is equal to the target. Okay, now right now this match target is not okay, so this matches target is not true right now, because here this run this just algorithm. Okay, when I'm going to run it for the first time, it is going to give me the infinity. Okay, so we will see how it is going to give the infinity, but just remember that right now it is going to infinity because there is nothing. Okay, so right now 0 to 1 it is going to give me infinity only. Then what we need to do here in my step 3, then in my step 3 I have to iterate through each edge to adjust its weight if necessary. Okay, that's what I need to do here. So here let's move over step 3. Okay, I will write this code later on, run Dijkstra's. Okay, it is very simple. So here let's iterate over all the edges. So here write for int h edges. Okay, and inside this just check. Okay, so here if my edge 2 is not equal to -1, then we have to just continue now, because we have to skip edges with non-weights, right? So here I'm writing if edge of 2 is not equal to -1, then in that case continue. Okay, and after that we have to set edge weight to a large value if current distance matches the target, otherwise we have to just set it to 1, right? So here edge of 2, okay, so if it matches the target, okay, matches target, okay, then in that case just set it to infinity, otherwise just set it to 1, right? Okay, and then after that again we have to add this, okay, graph dot add, all that stuff. So here just go here, so here just write graph dot edge 0 add new int edge 1 edge 2, okay. So here edge 2 is going to be 1, okay. I am going to set it to 1. So since see here this example 0 to 1 we can move in 1, 1 to 2 I can move in -1, 2 to 3 I can move in 1, okay. So let's suppose my source is 0 and my destination is equal to 3 and target is equal to 3. This is what I need. So first I iterate over this 0 to 1, 1 I don't need to change it, 1 to 2 I change it to 1, okay. This is done. Then 2 to 3 it's already 1. So I already reached 0 to 3 in just 3 target, right? So then after 0 to 3 I don't need to change it this because my target is already achieved, okay. So I'm just going to set it to infinity. Infinity value is nothing but 2e9, okay. So that's the meaning of the simple part, okay. Then after that just write the step 4. If current shortest distance doesn't match target, okay. So if it is not match target, then what we need to do, okay. If it doesn't match this target, not equal to matches target, okay. Then here we have to compute the new shortest distance with the updated edge weight. So here int new distance is equal to, again run Dijkstra, we have to pass source, we have to pass destination, okay, all that stuff, okay. Then again I'm just going to check if my new distance, okay. So here if my new distance is less than equal to target, okay, then in that case I will just set it to match this target, okay. That simply means that once I reach the end, okay. So here I'm just going to update it to match target to true, okay. And I'm just going to add the remaining value, right? So add to value, I'm just going to set it to target minus new distance, okay. So see here, here I did that same thing somewhere, yeah. 3 to 4 with 1 I reached, okay. I completed the source destination part, okay. But here instead of 1 it was good for me to add 3, right? So that's what I'm going to do here, target minus new distance, that's it. If my new distance is less than equal to target, then definitely we can update my edge to, okay, to target minus new distance. But if it is infinity only, so in starting when it was nothing -1, so that simply means infinity. So in that case the overall new distance is going to be infinite, nah, greater than target, then we don't need to prove this part. But if somewhere we get that our new distance becomes less than equal to target, then we can simplify that, okay. So this is the simple meaning of this one. And once this is done, then we have to just return, okay, if it matches target. If it matches target, then just return the edges, okay, or simply return empty array, okay, if it doesn't match the target. That's it, okay. So now let's run the Dijkstra algorithm. So it is going to be very simple. Code is a little bit big, right? So here private int run Dijkstra, and here what are we passing? We are passing n number of nodes, we are passing the source, we are passing the destination, okay. Or you can, yeah, into destination, okay. And here inside this how we are going to check. So I have told you now, first we need to create one min distance array, and then after that use a priority, okay, min heap we have to create. So and after that here just write new priority queue, okay. And here let's say we have two parameters a and b, okay. So I have to just arrange them based on their distance. So here I have to write a1 minus b1, okay. This is done, okay. So now after that, okay, so now after that just fill all the values to infinity in the starting arrays dot fill min distance, and I'm going to set all the values to infinity, okay. And here we are doing that now, we are setting all the values to infinity, then we have to update one by one. So this is the procedure for that. So here I'm going to add first in min heap, I have to add my source and the distance that is going to take to reach the source from source itself. So it is going to be 0 only. So here I'm just going to write min heap dot add new int, and in this I'm just going to pass my source and 0, okay. And then after that I am going to check, I'm just going to run one while loop while my min heap is not empty. Min heap is not empty, okay. So in that case what we need to do here, just take the current array outside. So current array is min heap, okay. So I'm just going to add the values in the current array of this min heap dot poll, okay. So now it is going to read, okay. So this is my current array. So in this there are two values, one is my source and one is my destination. So here I'm going to treat my source as u, so it is nothing but curve of 0, and my destination I'm just going to take it as curve of 1, okay. And there is one thing that if my d is greater than min distance of u, then in that case I don't need to update now. So I wasn't updating if it is 0, I was not updating it to 1, okay, since this value is less than 1, right? So here if that is the case, then simply do the continue, okay, and then just iterate over the neighbors as well for int So here graph, and here just pass my source. Okay, so inside this we have to take the destination. Okay, b is equal to neighbor of 1. Okay, and we also need the weight, so weight is at first position, right? Weight is equal to neighbor of 1. Okay, it should be 0 now. It's 0, it's 1. Okay, so we are iterating the graph now. So in graph, how we are adding the values in graph like this. First we are adding the destination, and then we are adding the our distance. Okay, so here initially it was empty, right? So I need to fill out these details one by one in this. So now this is done, right? And then after that, here just do one thing. Just check if d, okay, plus weight is less than min distance of v. Okay, so min distance, copy this, min distance of v. Okay, then in that case we have to just update my min distance of v to d plus weight. Okay, so that's what we are doing now. If it was 1 infinity and we get the new as smaller than the previous min distance, then we were updating, right? And we are also adding the same to min heap. Min heap dot add new int. Okay, and my min heap, what I'm going to add, I'm going to add my v. Okay, and then we have to add the min distance of v. That's it. So that's all we need to do as part of this code. Okay, and in the end just simply return min distance, and here instead of v just write a destination. Okay, so now let's try to run the code and see if there are any code issues. We will try to fix that. So the test case has been accepted. Now let's submit it. So see, our solution is accepted, right? So now let's just go over the time complexity for this problem. So let me just minimize the size. So how many lines of code? 58. Okay. So first I'm creating one graph, right? And then I'm iterating over all the nodes one by one. Okay, so here my time complexity is going to be O of n. Then I'm iterating over all the edges. Okay, all the edges in my graph. So here let's say my time complexity is going to take O of m. Okay, so O of n here plus O of m, right? Then after that we are running this method. Okay, we are calling this method on Dijkstra algorithm. So inside this algorithm we are using the priority queue. Okay, so we are using priority queue, right? And we are moving over all the nodes, okay, and all their edges also. So here for that I am going to say that my time complexity is going to take here of n plus m log of n. Okay, this is going to be my time complexity. And once this is done, okay, so once this is done, then after that we are again iterating over all the edges here, right? And for all the edges, okay, so if it doesn't match the target, okay, and let's suppose if all the edges is not equal is equal to -1, then we have to do all these steps again, right? Then again we are calling this run Dijkstra algorithm, right? So here also I need to move again, do the n plus m log n operations, okay, because because this run Dijkstra algorithm, okay, this is going to take always n plus m log n, because we are using min heap in our Dijkstra algorithm. Okay, but I'm saying that we need to perform all this again if my edge 2 is equal to -1, if my all the edges are -1. So let's suppose k edges, there are number of k edges which are -1, then for all the k edges again I need to do this. Okay, so my total time complexity is going to be first n plus m log n, okay, because of this run Dijkstra algorithm, right? And also it is going to be of k into n plus m log n for the k edges which are -1, okay, for which I'm going to call the run registers. Okay, so here O of n plus m, okay, number of nodes plus number of edges, and on that I'm using the min heap, right? So this is going to my time complexity. And in this, if let's suppose k are the edges which are -1, so on that also I'm implementing this n plus m log n, right? So this is going to be the time complexity for this problem, right? And we can ignore this smaller, right? O of n, O of m, if you want you can add that. So we have this O of n for graph creation, then O of m for all the edges visiting. Okay, all that stuff we are doing. So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.